Everyone, today we are going to see about Linux symlinks with hard links. Symlink is a symbolic link. It's basically Windows shortcuts, and Linux we are calling as a symlink or symbolic link. It's just pointing to another file. So creating a symlink, this is a command to create a symlink. Let me explain what is symlink and hard link and difference. Symlink is basically, this is the original file, my file.txt. In this example I am taking. Then if you see here, my softlink.2, it's pointing to that original file. Again, my softlink is pointing to this original file. Basically you can point to n number of shortcuts, but it's not pointing to inode, it's only pointing to the file. If this file deletes, my file.txt file has been deleted, what will happen now? This two links will be broken link. Two links will be broken link here. Again, so that is a symlink concept, how it is working. Then hard link, if you see, it's directly pointing to inode. So another symlink, another hard link I'm creating, my hard links 2, that's a example file name, but it's pointing to inode. When you delete this link, this hard link, what will happen? Still you can see the content, retrieve the content from this link to this inode. But when you delete here in symlink, you can't retrieve the file, you can't see the file content. But here, if you have around 10 hard links to the same inode, until if you delete 10 files, you can still retrieve until the 10 files, you can still retrieve it. Let me showcase. Okay, so this is already I created a symlink for, you can note of it. L means symlink, this file is symlink file. Another L means this is a symlink file. Another L is another symlink file. That original path is linux test.out. I'm going to delete this file. You watch what's happening now. Linux test.out. So we talked about broken links. So this all the files are broken link now. Again I want to activate this broken link to normal. Okay, I'm going to create again these files, linux test.out. So through cat command itself we can create a file, symlinks. Oh, control D. Then when you do ls, our all the symlinks has been active. This is the original path. This file is locating, and you can use cat command to see what is the content is available under this path. Yeah, this is symlinks content. Okay, now what are other places can I see the symlinks? Yeah, go to user bin folder. You will see lot of symlinks. Let me filter it out. Grab, start with L. See, the start with L is symlinks. This is a permission. We know then L means that's a link. Yeah, to understand clearly, man command is the perfect man. So the original path is etc alternative man. The man command is residing and staying here, etc alternatives man path, but we are just referring under user bin folder. Likewise, go to Linux user sbin also, you can find it out. Lot of symlinks and hard links also you can find it out under this paths. So that is a benefit, that is a use case. Inbuilt Linux also using this. Yeah. Okay, we talked about what is symlink and how to create. Maybe I can show you again. So this is the original path, then new Linux. I'll show you again one more symlink I'll create and show you. test4.out / linux test.out. Okay, let me check what is the error. So we how to create that's that's a path is Linux. We have to give the file path Linux test.out and test4.out on this path. Okay, now we can able to create this test4.out and this is pointing to all the 4 symlink is pointing here Linux test.out. And we faced an error, so we used first this and second this one, this is wrong, so we faced an error. How we can create proper? We have to create the file path then link, then we can able to create it. That's a way of symlink creation. Okay, can point to files directories is on different file systems. Symlink we can able to find different file system. I'll show you that. See here, this is the root disk / AGB disk. Another disk is like NV1N1. This is /data. Under /data, we are going to do the symlinks. Let me go to /data path. Already I done for testing purpose. Test.out. Again I'll try. So Linux test.out. I'm doing another name test1.out. Now we can able to do cross file systems also. I can able to do now cross file systems, different file system I can able to do in symlinks. We can able to do, but when you try the same thing in hard links we can't able to do. I'll show you that the same example. I'm just trying test2.out. If you try, it's a hard link, fail to create hard link, file name is test2.out, invalid cross device link. I'm just using AWS EC2 instance. This instance contain 2 EBS disk. I'm trying from one device, one EBS device to another EBS device. That means different file system. You can't cross link in hard link, but symlink we can able to do. This is the main difference usage. And as a example, this example you can note of it. The inode is directly pointing. That's both are real main difference. Okay. Then next one is how to unlink. That's simple Linux command. You can do unlink test.out. It will be the link has been removed. Okay, what is inode? Inode stands for, inode we are talking in symlink and hardlink. Inode stands for index node and it's contain owner, creation date, size, number of links, access rights, last date, everything is stored here. Okay, in practical, where can I see the symlink? Where can I see my inode? What is my inode number? Okay, this case I'll show you in one way. If you use df-ih, how much inode has been used in my file system? This is root disk. In this root disk, totally 3% has been used it for this disk. Here only 1% for data disk. So some of the real-time use cases we have faced, there is no space left on the device. So during this error, when we come and check, assume like 100 GB disk is there and 50 GB disk will be free, but there is no left space on error we are getting it. During the time, what we are checking, when you use is inode is eat up more or not. So with this command you can find out is this disk has been occupied or inode has been occupied. You can identify with this. Then I want to know what is my inode number for this file. That is a state command. Just do test1.out. So you find inode is 13 because this is /data. It's a new. Here I didn't save lot of files. It got very earlier number of 13. At the same thing, if you go to new Linux folder is under root folder path. Just try the same thing for test.out. So inode number is high. That's a different. In Linux, everything, each and every file have one inode. Each and every file should contain one inode. That's a concept. Even disk, contain even disk also. Everything considered as a file. That's a base of Linux concept. It is a disk or pen drive or hard disk, whatever Linux seeing as a it's a file. Second, each file and directory contain one inode for this. Yeah, hope this clear on this video, and yeah, thank you for watching, and let me know, please comment in the comment section, and let me know if any question on this. Thank you so much.